So welcome students. So in this question, you're given a hyperbola xy is equal to 7x plus 5y. You're asked to find the lattice rectum of this hyperbola. So what is the lattice rectum of this hyperbola? So as you can see, this is not a standard hyperbola. The standard hyperbola usually looks like x square by a square minus y square by b square is equal to 1. And if you have a standard hyperbola, it's very easy to find the lattice rectum. X square by a square minus y square by b square is equal to 1. If you have this, the lattice rectum is 2b square by a. But this is not a standard hyperbola. But this is a hyperbola related to xy is equal to c square. So you also studied a hyperbola which looks like xy is equal to c square. We can find the properties of this hyperbola also very easily. But this is also not directly of the form xy is equal to some constant. So first what I do is, let me try to convert this into this form. Then let me try to analyze it later. So first my aim is to convert this into this form. So obviously I cannot directly convert it as it is, but these two look related. So maybe what I guess is this is a shifted hyperbola correspond to this. That is, if this is of the form, instead of xy is equal to c square, x minus h into k minus y is equal to c square. What does it mean? That means that this is exactly same as this hyperbola, but it is shifted to a point h comma k without changing the direction. So now let me try to convert this into this form. So I have xy minus 7x minus 5y is equal to 0. So what I do is, here I have x into y minus 7 minus 5 times y, I'll write minus 7 is equal to, so what I have written is xy minus 7x minus 5y. You have an extra plus 35, so I'll add 35 here. So this 35 and this 35 are getting cancelled. So if I take y minus 7 as common, I get x minus 5 times y minus 7 is equal to 35. So now this is of the form x minus h into y minus k is equal to c square, where this is my c square. Now what does this mean? This means that this is a shifted hyperbola correspond to this. If I want the length of lattice rectum does not change by shifting the origin. That means if xy is equal to c square looks like this, x minus 5 into y minus 7 looks the same, but the center is going to 5 comma 7. So it looks like this curve. So if I want the lattice rectum, I can as well find the lattice rectum of this. So if I find the lattice rectum of xy is equal to 35, that will remain the same. This lattice rectum of this is same as the lattice rectum of this. But how do you find the lattice rectum of this? Is there any formula for you? So you know the conversion between the rectangular hyperbola and the form xy is equal to c square. What is the theory? X square minus y square is equal to a square when the axes are rotated through 45 degrees becomes xy is equal to a square by 2. So this is the theory. X square minus y square is equal to a square gets converted to xy is equal to a square by 2. Now I have xy is equal to 35. If I convert it back into this form by rotation of axis, so what does this hyperbola become? X square minus y square is equal to, so if this is a square, this will be a square by 2. So if this is a square by 2, this will be a square, that is double. So whatever is here, you will have double of that. That is xy is equal to 70. So xy is equal to 35 gets converted to x square minus y square is equal to 70. This is a rectangular hyperbola where a square is also 70, b square is also 70. That is x square by 70 minus y square by 70 is equal to 1. A square and b square both are 70s. So what is the length of lattice rectum? The length of lattice rectum is 2 into b square is 70 by a is root 70. That is equal to 2 root 70. So 2 root 70 is the length of lattice rectum of this hyperbola. Thank you.